We're always on the hunt for the next big thing in clean energy. But what if a really powerful solution was hiding in plain sight? I'm talking about one of the most basic forces in nature. Today, we're going to dive into a super clever system that's designed to generate electricity using, believe it or not, just the simple power of buoyancy.
I know. It sounds almost too simple to be real, right? But the whole concept we're about to break down is built on exactly that idea. It's all about grabbing that huge natural upward push that things feel in water and figuring out how to turn that into electricity we can actually use.
So, okay, how does this whole thing actually work? Well, it all kicks off with some really basic laws of physics. Seriously, stuff you probably learned way back in science class. We're not reinventing the wheel here, not at all. We're just taking that old school knowledge and using it in a really, really smart new way.
Okay, and here's the mission, boiled down to its simplest form. The entire goal is to take that powerful upward shove an object gets underwater, its buoyancy, and turn that straight up and down motion into the spinning energy that a generator needs to make electricity.
All right, so before we dive into the machine itself, let's just do a super quick refresh on the science that makes this whole thing possible. And it all comes down to the basics of buoyancy.
So here's the key thing to remember. Whenever you put something in water, the water pushes back up on it. That upward force, that's buoyancy. And how strong that push is, well, that's what decides if the object is going to float or sink. Simple as that. And this diagram, it's a perfect illustration of Archimedes' principle. So just look at object A. It weighs 500 kilograms, but it's pushing aside a cubic meter of water, and that water weighs 1,000 kilograms? See? Since the object is lighter than the water it displaces, boom, it floats. Now, object B has the exact same weight as the water it's displacing, so it just kind of hangs out there, neutrally buoyant. And then there's C. It's way heavier than the water it's pushing away, so down it goes. It really is all about density.
Okay, so the real secret sauce here isn't just that buoyancy exists, it's being able to control it. That's the key. For this thing to generate power, the object, and yeah, let's just call it a buoyancy tank, it has to be able to rise whenever we want it to, but then, to get ready for the next cycle, it also has to sink on command. The entire system, the whole genius of it, is built on being able to flip that switch between floating and sinking.
All right, now let's get to the good part, the heart of the machine itself. We're going to look at the actual mechanical cycle that lets this tank switch between sinking and rising whenever it needs to. So if you could peek inside one of these buoyancy tanks, you'd find a few key parts. There's a piston, and then there's a set of weights that are controlled by a little winch. And it's the really clever way these parts work together that lets the tank basically change its own density on the fly.
The whole process is actually beautifully simple when you break it down. Step 1, to sink. A valve just opens up, water rushes in, and the tank gets heavy enough to go down. Step 2, to rise. The system has to somehow push all that water back out, making the tank light and buoyant again. Now, letting the water in, that's the easy part. But pushing it out, well, that's where the real trick is.
And that brings us to the million-dollar question, right? The critical engineering puzzle. Think about it. When that tank is sitting at the bottom, it's got all the weight of the water above it pressing down on it. That's a ton of pressure. So how in the world do you force water out when there's so much pressure trying to force it in?
Well, the answer, believe it or not, comes from another fundamental principle of physics, Pascal's law. And what it basically says is that if you apply pressure to a fluid that's trapped in a container, that pressure spreads out evenly in all directions. And that is the secret to fighting back against all that outside water pressure.
Okay, check this out, because this is where it all comes together. On the left, you see the tank just sitting there. The water pressure inside and outside is totally balanced. But then, look at the right. The system drops those heavy weights right onto the piston. What does that do? It massively cranks up the pressure inside the tank, making it way stronger than the pressure outside. And once you have that imbalance, whoosh, the water gets forced right out. It's just brilliant.
So, there we have it. We've got a tank that can now shoot to the surface whenever we tell it to. The next piece of the puzzle is, how do we turn that simple upward motion into actual electricity?
It's actually pretty straightforward. As that now super buoyant tank rockets upwards, it's pulling on a rope. That rope is connected to a drive gear, which takes that straight line pull and turns it into a spinning motion. That spins a drive shaft, and that drive shaft powers the generator. It's just simple, direct mechanical power. Now, you don't want your power to be all jerky, right? On, then off, then on again. So to solve that, the system just uses two tanks working in tandem. While one tank is rising up and making power, the other one is already at the top, filling up with water and getting ready to sink. They just take turns, and that back and forth cycle guarantees a nice, smooth, continuous flow of energy to the generator.
Okay, so the physics totally checks out, and the mechanics are pretty clever, but here's the big question. Does it actually make enough energy to be worthwhile? Let's take a look at the numbers and see how this thing could potentially scale up.
All right, so every cycle has a bit of an energy cost, right? You got to spend some to make some. The main energy input here is the work it takes to lift that 250-kilogram piston and weight assembly back up, and that costs the system around 2,450 joules.
But now let's look at the payoff, the energy output. That very same tank, as it rises just 3 meters, generates a massive 17,640 joules of work. That is a huge difference.
And this chart really just puts it all into perspective, doesn't it? Look at that tiny little bar for the input energy, and then look at the huge bar for the output. We're talking more than 7 times more energy coming out than what you have to put in to run the thing. That's a serious net energy gain on every single cycle.
And this is where it gets really, really exciting. A single one of these tanks, if it completes a cycle every 12 seconds, could be a 1 kilowatt system. Now, what if you hook up 6 of them to one generator? You've got a 6 kilowatt system. But the real beauty is that this is totally modular and scalable. Just imagine building much, much bigger tanks and putting them in a dam, or even out in the ocean. You could potentially be generating hundreds, or maybe even thousands of kilowatts of clean power.
So it leaves you with this really fascinating question, doesn't it? Could the future of clean energy really be hiding in something as simple as sinking and floating? I mean, think about it. It's a concept that uses basic physics in a really smart way. It's scalable, it produces way more energy than it uses, and it runs on water, one of the most common things on Earth. It really makes you wonder, what other incredible, simple ideas are just waiting to be discovered, maybe hiding right beneath the surface?